Hello everyone, this is Alexander Lavranyuk with a lab report on Lab 1 Physics 2211 on constant velocity. So, firstly, let's see, we have a table of contents, what we will discuss in this lab. Then, let's go to the introduction. This lab was aimed to learn how to predict and simulate the motion of an object that has constant velocity in GlowScript. Also, we tried to recreate that and create a movement which would be nearly at constant velocity in the real world and analyzed whether the constant velocity is actually possible. One of the main principles we used for that was Newton's second law. It states that the acceleration of the object depends on its mass and net force acting on it. We assume that net force is zero because during the small piece of time that video was filmed, it would not influence it much. So we counted drag and air resistance to be nearly zero. So if mass is not zero and net force is zero, then the acceleration is zero. So we get the constant velocity. So this is a preview of results which we have gotten from our model. But let's firstly discuss how did we get these results and what do they mean. So, firstly, let's get to the tracker software. It was a software which we used to track the motion of an object which was rolled on a smooth surface. And we exported the data about its position and velocity and plotted the graphs. We plotted them using the computational model, which also helped us model the predicted velocity and the position in this situation. So, firstly, we input mass as 1 because mass, as there is no acceleration, does not really influence this situation. Then, first two lines after that are the initial conditions for position and velocity of the predicted object's movement. Then we also input the tracked object's movement, and we set time to 0 as the clock should start, and delta time to the delta time in the tracker. So then we export all the information and create a cycle which loops for exactly 3 seconds, because that's the length of our experiment. And what it does, it extracts the information from the data that we had and plots the both tracked and predicted velocity and position on the graph. So what do we have here? We get these two graphs, which I showed you before. And the green line is predicted data, the red line is real data. As we can see, at first with the position, we see that the difference is nearly negligible, although it still exists. So we can see that the real position was just a bit smaller than the predicted one. It is exactly because of the air drag and the net force, which is close to 0, but not exactly 0, that we did not count in our prediction. The same with velocity. Yes, velocity has spikes and peaks, and it's very unstable when it was tracked because tracker compresses the video into its own amount of frames. So tracking was a little bit unstable. However, you can still see the general trend that velocity is decreasing. And generally, its magnitude is smaller than the predicted velocity. That's why it got the position which is also smaller. So let's discuss some of the interesting questions. For example, what would happen if we switch the minus x and plus x axis? Let's return back to the position graph and discuss it first. So the only thing that would happen, that movement would start in the minus x position, but it would be the same value, just negative, and it would move to the same values but positive. We would still have that the real position is just a little bit smaller than the predicted one, but we would just reverse the graph. The same with velocity. The only difference would be that all the values would be multiplied by -1 to make them non-negative. So basically, it would be a symmetrical graph like that. What does the net force mean if it's 0? So that's a great question. And I wanted to say that basically net force means 0. It means that there is no actual force on the object, or all of the forces are countered by each other. So it means that the object would move with constant velocity. However, as we can see and as we can conclude from our experiment in the end, we understand that it's extremely impossible in the real conditions to achieve zero net force. But we have achieved the net force, which is extremely close to zero, as it was shown by our results on the position, which was just negligibly different from the predicted data. So this is the end of my lab report. Thank you very much all for your attention.